Today I am going to discuss investment analysis by decision trees. How to take decision to purchase a plant. The problem is narrated here. AB Limited is evaluating the purchase of a new plant that requires an initial investment of rupees 20,000. The plant is expected to operate for 2 years and will have no salvage value at the end of its life. Okay. The expected cash flows of each of the 2 years along with their respective probabilities are provided in table 1 and table 2 that will show in the next slide. Assuming a cost of capital of 10%, construct a decision tree using the given data and recommend whether the company should undertake or purchase the project or not. This is the problem. First, see the data. This is the table 1 and table 2. The cash flows for first year are 8,000, 11,000 and 15,000. I will show how to draw in the decision trees. And the probability of occurrence for the first year 8,000 is 0.3. This is the probability for occurrence of 8,000 cash flows. And the probability for occurring 11,000 cash flows is 0.4 and 15,000 cash flows is 0.3. Okay, this is the cash flows with probability for the first year. Now in table 2, the cash flows with probabilities are given on the happening of these cash flows. That means in the second year, if the cash flow option is taken 8,000, then the cash flows for second year will be 4,000 with probability 0.2, 10,000 with probability 0.6 and 15,000 with probability 0.2. If the cash flows is 11,000 the first year, for the second year the cash flows will be this: 13,000 with probability 0.3, 15,000 with probability 0.4 and 16,000 with probability 0.3. And if the cash flows for first year is 15,000, then the cash flows relating to this option will be 16,000 for the second year with probability 0.1, 20,000 with probability 0.8 and 24,000 with probability 0.10. Okay, these are the data given to take decision whether should we go for purchase the plant or not through decision trees technique or tools. Now how to draw the decision trees? See, actually this is the decision trees. This is the decision point. The choice options is purchase, no purchase. If purchase, then this is the chance option. As it is written, cost of capital 10%. Chance option, this is first year. First year, the chance of cash inflows rupees 8,000, 11,000 and 15,000. It is 15,000. Okay, this is the first year figures. The occurrence probability is the occurrence of 8,000 cash flows with probability 0.3 and the occurrence of cash flows 11,000 0.4 and the occurrence of cash flows 15,000 is 0.3. It is given in the first table. This 8,000, 11,000, 15,000. This is the probability that just written in this option. Okay. Now for the second year, if the cash flow is 8,000, then for the second year the cash inflows will be 4,000 with probability 0.2, 10,000 with probability 0.6 and 15,000 with probability 0.2. In this way, if the cash inflows for the first year is 11,000, then second year the cash flows will be 13,000 with probability 0.3, 15,000 with probability 0.4, 16,000 with probability 0.3 in this way. And if the cash inflows for first year is 15,000, then the cash inflows for second year for this option will be 16,000 with probability 0.1 and 20,000 with probability 0.8 and 24,000 with probability 0.1. Always keep in your mind that the sum total of the probability will be 1. You can check it, 0.1 plus 0.8 plus 0.1 is equal to 1. In this way you can check for this also, 4, 3, 7, 3, 1 in this way. Now how we will solve the problem? Okay, how we start? we will start from the end point, from the last point. First I am calculating the expected inflows, cash inflows, the expected cash inflows for this option of this second year. How will find out the expected cash inflows, expected revenues or expected cash inflows after second year for this option? This is 4000 into 0.2 occurrence probability plus 10,000 into 0.6 and plus 15,000 into 0.2, and if you add then you will get 9,800. This is the expected cash inflows for this, that is after second year. Then what will be the present value? That is at this point, this expected cash flows, that means 9,800 into 0.909, because the discount factor for 1 year back, that's the present value at this point. That's why we are multiplying 9,800 the expected cash flows into 0.909, and the figure will come to 8,908. That means at this point the total cash flows will be 8,000 plus this 8,908, that is 16,908 for this position. Now for this option, the expected cash inflows for this, the expected cash inflows for these options will be 13,000 into 0.3 plus 15,000 plus 0.4, 16,000 plus 0.3. If you add, then you will get 14,700. This is the expected cash inflows at this point for this option C12. Then what will be the present value at this point? That means you have to multiply 14,700 into 0.909. This is the discount factor for 1 year, because we are going back for 1 year. The total cash inflows at this position will be 24,362. Now if we take this option, and what is the expected cash flows? What is the expected cash flows for this? That is 16,000 into 0.1, 16,000 it is calculated here, 16,000 into 0.1 plus 20,000 into 0.8, 20,000 into 0.8 plus 24,000 into 0.1. That is the expected cash flows will be 20,000 for this option. And what is the present value at this position? That is 20,000 into 20,000 into 0.909, 20,000 into 0.909, and that means if you add with the cash inflows at this point, that is 18,000, the total 18,000 plus 18,180, that will be 33,180. Now we have got the cash inflows at this position, and at this position. At this position the cash inflows is 16,908. At this position the cash inflow is 24,362, and at this position the cash inflow is 33,180. Now we have to find out the expected cash flows of this. What is the expected cash flows? The occurrence probability of this is 0.3. That's why the expected revenue at this point 1 is 16,901 into 0.3. This is the probability of occurrence probability 0.3 plus this is how much, 24,362 into 0.4 plus 33,180 into 0.3. And what is the total expected cash flows at the end of first year? That will be 24,771. Now we have to again back 1 year to get the initial point where the investment is being made. That's why you have to discount this value to the present value. And how will do it? That is 24,771 multiplied by 0.909. This is the discount factor for 1 year. To get the present value at this point, that means initial point, you have to multiply it with 0.909, and the expected cash inflows at this point will be 22,517. And how much you have invested? The initial investment or outflow of fund is 20,000 for this project, and hence what is the net present value at this point? Net present value is, this is the inflow of present value 22,517 minus 20,000 is the outflow. This 2,517 is the net present value. As this is positive, that is greater than 0, that's why we can accept the project. The final decision is the project should be accepted or the plant should be purchased. In this way you can solve the investment decision to any project or selection of a plant having cash flows with probabilities for different years. If you have any doubt, then you please mention in the comment box. I will definitely reply at the earliest possible. Then what steps you have adopted? First you have to draw the decision trees, and from the last you have to move to the beginning. From the last you have to find out the expected cash flows, then discount that expected cash flows to the respective year, and finally you have to back to the initial point and compare with the cash outflows. In this way we have taken the decision. Thank you very much.